introduction to exercise 2.6 on the Newton's method. Now, the idea of the Newton's method is it's a technique for solving equations in the form of f of x equals to 0. So we solve for x when we let the whole equation equal to 0. Right? Oftentimes we're presented with an equation that doesn't factorize nicely into like so it's something we can apply null factor theorem or something like that, right? So we might have to use a brute force method. Now, of course, you can just put that into the calculator and see what you get, right? But we're going to approach it using Newton's method. The idea is that, essentially, as I mentioned, it's trial and error with a process. The idea behind this, oh my gosh, who wrote this, is to start with an initial guess, which is reasonably close to the root. Now, when we say root, it just means your x-intercepts, essentially, right? Then to use the tangent line to obtain the x-intercept that is even better than the original guess. In principle, what that means is this. We're going to apply this formula, and then just keep applying it as many times as the question asks. Any questions? Okay. I'm going to go through the process, and then I'm going to explain how to do it by hand first, but it gets very ugly very quick, so we'll use a calculator afterwards. So, pick an initial guess. Step 1 is pick an initial guess x0. Okay? Because that's not your first iteration. It's just called x0 because that's what we're starting off with. Such that f of x0 is about 0. There is no quote-unquote wrong answer, because if you just pick something that's further away, you're just going to need to do more trial and error guesses, yeah? But the idea is, we're going to go, for example, if this is the answer, we might start here, and then go here, and then here, and then here, and the answer is going to get closer and closer towards the answer that we should actually get, okay? We find the equation of the line, tangent to y equals f of x, at your original guess. And then we follow it back, follow it back to the x-axis at the new guess, x1. Now, it seems very complex, but it's just that formula. I'll show you what I mean in a moment. And then we do the same thing. With the new value of x1, we substitute that into our new formula, and we do as many times as the question asks. Let's put that into practice, because it's a lot more confusing than it looks. Sorry, it's a lot less confusing than it looks. Example 10, use Newton's method to approximate a zero, so it's looking for us a root, for the cubic function y equals to x cubed minus 4x plus 1. If x0 equals 2, so it's told us our original guess, find the value of x1. Let's do it. So, off the bat, right, I'm going to find the solution and then see if our answer gets there, right? So on my calculator, we already know we can just go, let's define f of x equals to x cubed minus 4x minus 1. Is that tiny up the back? Is that visible at all? Shall I resize it? Much better, isn't it? Alright, let's see if we can get this to be there. Is that a bit better or not really? No. A little bit better? Alright, we'll continue from here then. So, we hit OK. F of x equals to x cubed minus 4x plus 1. I'm going to go ahead and put in solve f of x equals 0. And let's see what we get. Oh, gross. Let's put in, there we go. Okay. Let's see if that's what we're working towards. The answers are, to me, negative 2.1149, 0.2541, and 1.861. I've rounded them aggressively, but these are ugly numbers. I mean, you shouldn't be able to do this by hand. So, I want you to imagine back in Newton's day, they didn't have class-pad calculators, yeah? So let's try to approach it the way that he would, though, given that you have to use brute force method. So let's say we don't know this information. We're going to start by saying, let's look at the formula. The formula says x of the next number equals to x of the number minus f of the number looking at, and then f dash of the number. So let's start by looking at x0 equals to 2. That's what we've been provided. Is that color hard to read back? Okay. x0 equals to 2. I'm going to find f of x0. Because that's what this one is right here. We're going to need that if we're going to be able to solve this process. F of x0 equals 2. And we're just going to put in 2 into my function. So that's going to be 2 cubed minus 4 times 2 plus 1, which gives me an answer of 1. 2. What? Sorry. That's 8 minus 8. Yeah, 1. There we go. Let's do the next thing. So the next thing in my formula says this one right here, which is f dash of xn. I'm going to skip a step because I'm assuming we're very comfortable with our derivatives. So if I substitute f of x0 into my derivative function, it ends up being 3 times 2 to the power of 2 minus 4, or 3x squared minus 4, substitute 2. Yes?
Are those both F's? Is that a D?
Which, this one? Yeah, sorry, I just have ugly handwriting. Yeah, they're both F's. Great. Now using the formula, right, I'm going to say, because let's look for x1. So x1 equals, and it says x of n, in this case xn would be not x1, it'd be x0, right? But I'm going to replace that with our number, because we already know x0 is 2, minus f of xn, so that's the one we found just here, which ends up being 1 over, and then f dash of xn, right, which ends up being 1 over 4. No, 4, not 4, sorry. I didn't even solve that. My apologies. That's 8. Here we go. 3 times 2 squared, that's 3 times 4. 12 minus 4 gives us 8, and then that becomes 8. I feel like I'm all over the place. Apologies. Which just simplifies to 15 over 8. If I put that in my calculator, 15 over 8 as a decimal equals, not equals, there we go, equals 1.875. Is that approximately one of the answers that we already had? Yeah, it's approximately a 1.861, but it's not a great estimate. So, and it says, I don't know if anything says to find x1. Let's find x2. Let's see if we get a bit closer. So, I'm going to go ahead and do this in the calculator, because by no means do I have time to do this by hand. So, we've defined f of x, right? What I'm going to do is I'm going to say f of x, instead I'm going to do f of 1.875, because I've already defined f of x as my function. So I know that that's going to give me, I'm going to switch this to decimals, because this is going to be, there we go, f of x1, there we go, equals to, and I'm going to approximate it to 0.092. 0.092. And then I'm going to put the differentiated version, and for this case, right, I'm not going to use interactive because I want the diff to be in my calculator screen as opposed to a separate window. So I'm going to go action, calculation diff, and it'll give diff. And then I'm going to put in f of 1.87. So that will give me the derivative . Okay, that's not right. 3x squared minus 4. Ah, sorry, that's right. We don't derive the equation that we substitute, because that's taking it in as the differentiation of when I substitute x equals to 1.875. We don't want that. We want it to give us the value after, right? So we say differentiate it and then sub it in. To do that, we have to do that given symbol. So that's going to be in your math 3, so keyboard math 3. And there's a straight line. Given that, x equals to 1.875, and that will give you your answer. So we get f dash of x1 is actually no, this one, yeah, we'll round it, approximately 6.5, we'll do 47, we'll keep it consistent, 6.547. So if we're going to then put in the calculator, into the formula, x2 would equal xn, which in this case is x1, which we know is going to be 1.875, minus the first value, which is 0.092, divided by our bottom value, which is 6.547. Any questions of where these numbers come from? Okay, I go 1.875 minus 0.092 divided by 6.547. That's number 7. There we go. And we end up with x2, which is approximately 1.861. Is that closer to our actual response? Yes, it is. It's much closer. And we can keep going. In fact, to streamline this process, what we can do is just put in, right, because I know the next number, for example, is going to be this one here. I can just put in 1.86. Oh, actually, you know what? Let's just put in x. X minus, I'm going to put my fraction in, which I don't know how to do on this screen here, but I'm just going to put in brackets to make it easier. I'm going to put in f of x over f derive, sorry, diff f of x, and then I'm going to give it a value. So I'm going to say x equals 2, and I'm going to use the previous answer. I've typed something in here wrong. X minus f of x over derivative of that, given x equals to that. Why is that giving me this? I'll figure that in a second. Not sure why it's doing that. But you can put in a process like this in order to get the same answer and just keep hitting enter by replacing the number in. Any questions about Newton's method? Okay, make sure you copy that down. In this case, it only says value of x1. In the next question, you can see, complete 2 iterations. So it means to get to x2. That's it. Okay, all good. When you're ready, let's get started on exercise 2.6 questions on Newton's method. And we'll go from there.